In the second half of lesson 13.2, we're going to look specifically at the unit circle. The unit circle is a circle centered on the origin whose radius is 1 unit. That's why it's called a unit circle, because the radius is equal to 1. What we would like to do with the unit circle is determine coordinates at various points along the way. So if I pick this point and make an angle with the terminal side here, this would give us an angle theta right here. If this angle theta turned out to be a 60-degree angle, then we can determine the coordinates to this terminal side by using special triangles. So if you remember from geometry, one of your special triangles was the 30, 60, 90. And the ratios in that triangle were 1, 2, root 3. In our unit circle, though, the hypotenuse is always 1 because the radius to the circle is 1, and the radius will always be the hypotenuse. So if we change our 30, 60, 90 here, so the hypotenuse is 1, we'd have to divide by 2. In order to keep the ratios the same, we'd divide all the sides by 2. So our 30, 60, 90 triangle can be used in the unit circle. If we make the hypotenuse equal 1, we know the x direction is 1/2 and the y direction is root 3 over 2. So the coordinate to this point on the circle would be 1/2 root 3 over 2. If you remember also from geometry, to calculate a cosine to an angle, you do adjacent over hypotenuse. Looking at our unit circle, the adjacent side actually this is for a 60-degree angle specifically, the adjacent side is 1/2 and the hypotenuse is 1. So that gives us a cosine of 60 equal to 1/2. The sine of an angle theta is opposite over hypotenuse. So in this picture, the sine of 60 degrees would be root 3 over 2 divided by 1. So the sine of 60 degrees is root 3 over 2. So by using a little bit of knowledge of sines and cosines and the special triangles, you can get various coordinates around the edge of the unit circle. So if we keep in mind that the radius here is 1, and that any coordinate on the edge of the circle can be found doing cosine theta for the x value and sine theta for the y value, we can determine some angles. So for a 90-degree angle, that would be the vertical angle that we have here. The coordinate at this point would be 0, 1. So the cosine of 90 degrees would be 0, the x value. The sine of 90 degrees would be 1, the y value. If we do negative 180 degrees, that's going to be coming around here. There's our terminal side. The coordinate at this point is negative 1, 0. So the cosine of negative 180 is the x value, negative 1, and the sine of negative 180 is the y value, 0. If theta is 270, starting in standard position, going in the positive direction, 270 would end right here. The coordinate here is 0, negative 1. So we can find that the sine of 270 is the y value, which is negative 1, and the cosine of 270 is the x value, which is 0. So we can find sines and cosines using our unit circle. Okay, since we already did the 60-degree angle, I'm going to change this to be a 30-degree angle. So if we have an angle theta of 30 degrees, we want to know the coordinates to this point on the edge of the circle. So what we're going to want to know then is the cosine of 30 degrees and the sine of 30 degrees. So if we drop a perpendicular here, that would give us a 30, 60, 90. We know that the hypotenuse is 1, and so the short side over here is 1/2 of the hypotenuse, and the longest leg is √3/2, as I showed you earlier using the special triangles. So the cosine of 30 would be the x value here, which is √3/2, and the sine would be the y value, which is 1/2. For a 225-degree angle, we're going to start in standard position, and we'll go through 180 degrees plus another 45 degrees. So we're going to end right here. We want to know the sine of 225 and the cosine of 225. So knowing that this is a 45-degree angle is going to help us. So we're going to drop a perpendicular here. This is 45, so this is 45. In your special triangles, that doesn't look good. In your special triangles, you had a 45-degree angle. In a 45, 45, 90, the two legs were 1, and the hypotenuse was √2. Since our hypotenuse is the radius of the circle, and we know the radius equals 1, we're going to have to do some manipulation here. So if we take √2 times √2, we know that equals 2. And then if we divide 2 by 2, that will give us 1. So we can get our hypotenuse equal to 1 if we multiply by √2 and divide by 2. So if I do the same thing on each of the legs, I find that each of the legs is √2/2. So in my unit circle, the hypotenuse will be 1, and each leg will be √2/2. Okay, but the x value is going left, making it negative, and the y value is going down, making it also negative. So that means the coordinate here on the edge of the circle is negative √2/2, negative √2/2. So the cosine of 225 degrees is the x value, which is negative √2/2. And the sine of 225 degrees is the y value, which is also negative √2/2. And that's it for this lesson.